Hey guys, welcome to a new video. In today's video, we're going to look at a Leetcode problem, and the problem's name is remove all adjacent duplicates in a string. In this question, we're given a string S, which consists of lowercase English letters. In this question, a duplicate removal consists of two equal and adjacent letters, which have to be removed from that string, and this has to happen repeatedly. So we repeatedly have to make the duplicate removals until S does not have any adjacent duplicates in it. So finally we have to return the final string after all such duplicate removals have been made. It is proven that the answer is unique. We are given a string S. So here in this question you can see two B's adjacent to each other. So this will become A because you remove these two B's. And again you see here two A's are adjacent, so you have to remove this. So this will become CA. And now no more duplicate removals can be made. So CA will be your final answer. So that is the matching answer here. Now let's see how we can build the logic. So now that we have the string S, we iterate through the string S from left to right, and we can use the stack data structure to build our logic. So we access one character at a time starting from the beginning till the end and add those elements into the stack and check if that element is already present in the stack. And then if it is present, we can remove that element from the stack. And finally, the elements present inside the stack will be our output. So let's build the stack. So initially you start with A. So add A into the stack. Now let's go for the next element. You're pointing at B. Now we check if that element B is equal to the peak element in the stack. No, it is not equal. So add that element into the stack. So stack follows the first in last out. So first in last out mechanism. Push the elements from the top and you also pop the elements from the top. So now you add that element B to the top and now you go for the next element. Next character is also B. Now we're using stack.peak. So using stack.peak you compare this element with the peak element inside the stack. Yes, they both are equal. If they both are equal, you pop that element out of the stack. So you remove B from the stack and you go for the next element. Next element is A. You check if A is equal to the peak element inside stack. Peak element is A. So they both are matching. So remove that element from the stack. Now go for the next character. Now stack is empty. So if stack is empty, you directly push it into the stack. Now go for the next element. Check if this element is present inside the stack. No, it is not matching. So add this element from the top. A will be added into the stack. Now we reach the end of the string. So whatever is present inside the stack will be our output. So here you can see stack has the letters AC, but at the order of occurrence is CA. So you reverse this using the reverse method on the stack. So you get CA as the output. Now let's take a look at the code. So here you can see that you're declaring the stack and then you're using a for loop to iterate through the string S. That is the input here. Now I'm accessing one character at a time and storing it into the character CH. Now we check if the stack is empty. If stack is empty, push that element into the, and here you're checking the topmost element inside the stack is equal to the current character. If it is that, then remove that element from the stack. That element is not matching, then push that character into the stack. So this will happen for all the elements in a loop. So this will happen for all the characters inside the string S. And finally you are building the output from the stack. You have our answer inside the stack. So until stack is empty, you keep popping the element and appending into the string builder. So string builder will have our output, and now the return type is a string, right? So the string builder is built from the stack. So now we have to reverse the string builder and then convert that into a string. So this will give you a string. So now the time complexity of this approach is O of n, where n is the length of the string S, and the space complexity is also O of n because we're using a stack to solve this question. That's it guys, thank you for watching and I'll see you in the next video.